last but not least, problem 25. How many sequences of zeros and ones of length 19 are there that begin with a 0, end with a 0, contain no 2 consecutive zeros, and contain no 3 consecutive ones? So basically what these sequences look like is we start with a 0. We have either 1, 1, or we have like 2 ones, and they're separated by zeros. Because we can't have 2 zeros, so zeros kind of just act as boundaries. And then we end with a 0. So we may notice here that zeros are the things which are simplest to work with, because if once we, like, for example, with this example, it has 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh yeah, this actually has, that was not intentional, but this actually has 19 exactly. If we were to take this and just get rid of all of these, then we can just assign either 1, 1 or 2 ones into each of these slots. And so we can just do casework on the number of zeros. Then, okay, so you're forced to have at least 1, 1 in each of these. So since there's 8 zeros, 7 ones are forced. And then you can place the remaining 4 ones in any of the 7 spots. But it can't be in, we've lucked out here because you can only have runs of 1, 1 or 2 ones. And so this gives us 7 choose 4, which gives 21 ways. So that's like, for example, if there's 8 zeros. But we can do this more generally. Okay. So n and number of sequences with n zeros. And in fact, we have that this value, this right-hand column, is going to be equal to 19 minus n minus 1. That's on the bottom, sorry. This is basically the exact same logic we did before. So there's 0, 0, 0, 0, 0, and then we place ones in between them. We assign at least 1 to each of them. So there's n zeros and there are n minus 1 ones. And so this is what remains. These are the extra ones we have to place. And n minus 1 is the number of the number of slots in between zeros where we can put the ones. And so, for example, for n equals 8, this formula would give us 7 choose 20 minus 16, 7 choose 4. We can also go down. So 9 would give us 8 choose 2, and 10 would give us 9 choose 0. And 7 would give us 6 choose 6. Yeah, okay, that makes sense. And everything beyond that would just become 0. Just because you can't fit the ones in the right amount. And so now we just have to add up these 4 binomial coefficients and we'll be done. So this is equal to 1. 7 choose 4 is equal to 7 choose 3, which is equal to 7 times 6 times 5 over 6. That's 35. This is 28, and this is 1. And adding these up, it's 35 plus 30, which gives 65. And we are done.